Hello class, this is a video tutorial on adding and subtracting surds and a continuation of this. We already know that like surds can add or subtract. So for example here, if we have 3 root 5 and 4 root 5, because they both have the square root of 5 as their surd, we can add the coefficients. 3 plus 4 is 7. But in this video, we're going to look at how, by simplifying surds, we can do further addition and subtraction of surds. So let's take a look at these examples. In this example, it looks as if we can't add anything because root 5 and root 20 are not like surds. But if we take a look at root 20, that is the same as root 4 times root 5, which will give me 4 root 5. This stays the same all the way through, plus 2 root 5, which simplifies down to 6 root 5. So this question actually simplifies down to this by first simplifying root 20. Let's do the next example. This is 5 root 3 will stay the same because root 3 is already simplified. And now 48 I can see is broken up into root 4 times root 12. But then I realize again that root 12, plus root 4. And I realize root 12 can be broken up into 4 times 3. And this will give me 5 root 3 plus 2 times 2. That will give me 4 root 3. And adding all of these together gives me 9 root 3. Once again, I can see 32 can be broken up into, let's put that plus down the middle, root 16 times root 2, and 7 root 2 stays as it is. This will give me 7 root 2 plus 4 root 2, 11 root 2. At this stage, if you wanted to, you could skip right down to this point, but it's good to show working so that you don't make any mistakes. Let's do a few more examples here. Now, with larger and larger numbers, I tend to just use my calculator and start testing perfect squares. So for example, 108, I'll just test randomly, divide this by 36. So it works. So 108 is actually root 36 times root 3 minus 50 I know is root 25 times root 2. 12 I know is root 4 times root 3. And 75 is square root 25 times square root 3. Okay, simplifying these, 36 becomes, this term becomes 6 root 3. This next term becomes 5 root 2. This next term becomes 2 root 3. And this last one becomes 5 root 3. Yep. And as I can tell from here, all of these numbers will add up to, well, let's do all the square root 3's first. 6 plus 2 is 8. 8, take away 5, gives me 3 root 3. And it seems as if this does not add with anything, but it stays in simplified form. Let's do these last two examples. 45. 45 is 9 times root 5. 24 is root 12 times, oh wait, no, let's break that even further. Root 3 times root, root 4 times root 6. Let's try that. 320, not gonna bother. 320 divided by, let's try 84. Nope, doesn't work. So let's try 320 divided by 4. 80 divided by 4. 20 divided by 4 is 5. So it's going to be root 4, root 4, root 4. That's 6 root 5. Okay, this will simplify into 4 times 4 times 4 cubed is 64. This will give me, 320 is negative root 64 times root 5 plus root 6 here on the end here. Adding everything together, this will give me 3 root 5 plus 2 root 6 minus 8 root 5 plus root 6. 3 take away 8 is negative 5 root 5. 2 root 6 plus root 6 is 3 root 6. One more example here. Square root of 8, I'll break up as root 4 times root 2. 12 is going to be negative root 4 times root 3. 27 is going to be 9 times root 3. And 108, let me test it again. 108 divided by 36 is 36 root 3. So plus root 36 times root 3. This first term becomes 2 root 2. This next term here, square root 4 is 2, so minus 2 root 3. Square root of 9 root 3 becomes positive 3 root 3. And this last term becomes 6 root 3. So it seems as if 2 root 2 stays as it is. There's no addition to it. And everything else will add. So this will give me negative 2 plus 3 is 1. 1 plus 6 is 7 root 3. So I hope that gave you an insight into the adding and subtracting of surds using simplification. Best of luck.